welcome back. I'm just going to take up from where Ms. Habibzada left off. So this lesson is about transformations of functions, and we are just going to carry on with some examples. Before that, I'm going to go over some of the steps you need to follow in order for you to transform a logarithmic function. This right here is a transformed logarithmic function with its parameters, and as Ms. Habibzada spoke to you about what each of these parameters do, we're just going to go ahead and do transformations of points to be able to graph other transformed functions. So before you start with this, it's always a good idea to know what your base graph is, and your base graph is going to be different depending on whatever your base of logarithmic function is going to be. So for example, if I'm graphing y equals to log of 2x, my base graph is going to have a base of 2. Keeping that in mind, there are some key points that we need to use before we go ahead and graph our base function. The key points in a logarithmic function basically has a y-coordinate of 0 and 1. So we have to think about what would be the value for x such that my y value is going to be 0. And as we know that we can always transform a logarithmic function into an exponential function, so converting this to an exponential function, it would be 2 to the power of y is going to equal to x. So if I'm taking that same concept and applying it here, I can know the value for x. So it'll be b to the power of 0, which is the y value. I'm just going to write that down here so you guys are able to see it properly. So b to the power of y is going to equal to x. So in this case, y is equal to 0. So b to the power of 0 is going to equal to x. And as we all know, anything to the exponent of 0 is always equal to 1. So 1 is equal to x. That means the value for x is going to be 1. Now, carrying that on with our second point, as we all know, b to the power of y is equal to x, and y value here is equal to 1. So b to the power of 1 equals to x, which is equal to b in that case. So it'll be b. Now, transforming that and applying our horizontal as well as our vertical transformations, if x is equal to 1 and we're just applying the transformations of our horizontal stretch or compression as well as a horizontal shift, our point is now going to be 1 over k plus d. And following that with our transformed point on the y coordinate, if y is equal to 0, 0 times y is 0 plus c is just going to be c. Doing the exact same thing with the second point. If x is equal to b, it's going to be b over k plus d. So essentially what I'm doing is I'm just plugging in the value for x in this equation right here, and I'm plugging in the value for y in that equation right there. So a times 1, which is a y value, plus c is going to be a plus c. Alright, so once we have our transformed key points, we are then going to figure out what our asymptote is, our new asymptote. I like to do this in the beginning, but it doesn't matter in which order you do this, but it's a good idea to keep in mind what your new asymptote is going to be, and it's always going to be whatever the value for d is, your horizontal shift. And if I just show you the general logarithmic function, if you notice there is a vertical asymptote, and the general logarithmic function looks like the following: y equals to log base x. We all know that since this right here is our vertical asymptote, and as we shift the graph horizontally, it's the asymptote that is also going to move. So when we have our new asymptote, according to our transformed function, we are then able to graph the function properly. And the fourth point that I have here is create mapping formulas and find transformed points, essentially what we just did in number 2 right now, and then we're going to graph the new transformed function.